It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system now.
Astronomers are watching a comet that shouldn't exist, one that's breaking the laws of physics in real time. And in just weeks, it's going to do something that will either prove we've misunderstood comets entirely or reveal something far more extraordinary. It's screaming through space at 135,000 miles per hour, fast enough to circle Earth in 7 minutes. But speed isn't what has scientists losing sleep. It's what this thing is doing. A plume of gas is firing in the wrong direction, directly toward the sun, fighting against forces that should be impossible to resist. It's headed for its closest pass to the sun at the end of October, and what happens then could rewrite everything we know. That was the shocking discovery from Hubble's observation of 3I Atlas, the third interstellar object ever detected. And it's not just passing through our solar system like a tourist. It's accelerating, generating thrust, behaving like it has an engine, an admission so unbelievable it sent shockwaves through the astronomical community. You see, a comet can't do this. It violates fundamental astrophysics, and this engine-like behavior, it's just the first clue that 3I Atlas might be something more than a comet. Welcome to NASA's nightmare. July 1st, 2025. A survey telescope in Chile picks up a faint smudge of light, but this isn't just another dot in the sky. It's moving at over 130,000 miles per hour, instantly flagged as an interstellar visitor, only the third one ever confirmed. They named it 3I Atlas, but nothing about this object is normal. Its path through our solar system is unusually fast and straight, a trajectory so extreme it shattered records before anyone even understood what they were looking at. Then, the big telescopes, Hubble and Gemini South, turned their powerful eyes toward it. What they saw sent a ripple of disbelief through the entire scientific community. The tail pointing the wrong direction? That was just the beginning of the nightmare. Comets have one job: point away from the sun, always, without exception. It's one of the most fundamental, observable laws of celestial mechanics, as reliable as gravity itself. Here's why. When sunlight hits a comet, it heats the icy surface. Gas and dust explode outward in brilliant jets. The solar wind, a constant stream of charged particles racing away from the sun at 1,000,000 miles per hour, catches this material and pushes it into a glowing tail. The tail always points away from the sun. It's Physics 101. 3I Atlas breaks that rule. Every new image from Hubble and Gemini South showed the same impossible sight: a bright, persistent plume of material pointing directly sunward, not at an angle, not slightly off, directly toward the star that should have been pushing it away. It's fighting against the very force that created it. This wasn't a glitch, not a temporary anomaly captured in a single frame. It was constant, sustained, visible in every observation across multiple wavelengths of light. Imagine finding a flag that blows directly into the wind. That's what astronomers are seeing right now. Scientists rushed to their computers, running every atmospheric model they had. None of them worked. The dust in this sunward plume is far too heavy to be moved by solar wind in this direction. Radiation pressure from sunlight can push small particles, but the mass and velocity observed here defied those calculations. Yet the material was clearly being ejected from the sunlit face with tremendous force, a complete contradiction. And identifying the problem was only step one. When astronomers measured 3I Atlas's path with extreme precision, they discovered something that made the impossible even worse. It wasn't where it was supposed to be. In space, prediction is everything. Know an object's position, velocity, and gravitational forces, and you can calculate exactly where it will be months later. Pure Newtonian physics. Comets sometimes deviate slightly because of outgassing, random jets of vapor that give tiny, unpredictable nudges. Scientists call this non-gravitational acceleration. Small, chaotic, random. But the force moving 3I Atlas isn't tiny, and it's definitely not unpredictable. Astrometric tracking confirms something extraordinary. 3I Atlas is not following a path dictated by gravity alone. There's a consistent, sustained force pushing it, and the direction of that push aligns perfectly with its impossible sun-pointing tail. This isn't a leak, this is propulsion. The force was estimated at 4 × 10 to the power of -7 meters per second squared. Sounds incredibly small, right? But over weeks, this gentle, constant nudge shifted the object's position by thousands of miles from where it should have been. To get that much push from normal water ice sublimation, the comet would need to be losing 10 times more mass than what astronomers can actually see. The numbers don't add up. Computer simulations reached a startling conclusion. The only way to match the observations, 3I Atlas must have a focused, sunward-firing jet, emitting mostly heavy grains of dust, not random outgassing, not chaotic venting, a directional stream of material producing measurable thrust. The estimated force? 0.4 millinewtons, tiny by human standards, but identical to the ion engines we use on our most advanced spacecraft. The comparison nobody wanted to make hung in the air. This looks engineered. If you're as fascinated by this as we are, hit that like button now, because what comes next gets even stranger. The propulsion mystery deepened when scientists analyzed what this comet is actually made of, and that's when things got truly mind-boggling. The James Webb Space Telescope revealed that 3I Atlas isn't just moving wrong, it's made wrong. When light passes through a comet's coma, the cloud of gas surrounding its nucleus, different molecules absorb and emit specific wavelengths. It's like a chemical fingerprint. Scientists can determine exactly what the comet is made of, one of the most reliable tools we have. What they found in 3I Atlas was shocking. Most comets in our solar system have a balanced ratio of carbon dioxide to water. They formed in the same stellar nursery we did, from the same materials that built our planets. 3I Atlas has a ratio of 8:1, overwhelmingly dominated by carbon dioxide. This composition screams foreign origin. It was forged around a different star, under wildly different conditions than anything native to our cosmic neighborhood. But the real wow factor? The metal. The telescope detected atomic nickel vapor in the coma, a lot of it. Nickel glowing in the ultraviolet, released as the comet heated up. But iron, nickel's constant companion in our solar system, was completely missing. Think about that. In our cosmic neighborhood, nickel and iron are forged together in the same stellar furnaces during supernova explosions. They cool and condense as a pair, always appearing together in asteroids, meteorites, and planetary cores. Finding one without the other is like finding left shoes with no right shoes anywhere. It just shouldn't be there. This bizarre chemical signature suggests formation conditions we don't have locally. A star system with different metallicity, different elemental abundances, different rules. Combined with the propulsion anomaly, the picture becomes deeply unsettling. This isn't just a visitor. It's a visitor that doesn't follow our rules, not just in how it moves, but in its very atomic structure. And this pattern of breaking rules, we've seen it before. In 2017, something streaked through our solar system that we still can't explain. Now it has company. It was called Oumuamua, Hawaiian for scout or messenger. The first confirmed interstellar object ever detected. Small, tumbling, shaped like a cigar or perhaps a pancake. It moved through our solar system on a hyperbolic trajectory, far too fast to be gravitationally bound to the sun. But its defining mystery wasn't its shape or speed, it was how it moved. Oumuamua displayed non-gravitational acceleration. Something was pushing it, altering its trajectory in ways gravity alone couldn't account for. But here's what made Oumuamua truly spooky. It had no tail, no coma, no visible outgassing at all. Telescopes searched for any sign of gas or dust being released, anything that could explain the push. They found nothing, yet something was accelerating it away from the sun. This led to a storm of controversy. The most famous, and most divisive, idea came from Harvard astronomer Avi Loeb, who proposed that Oumuamua could be an artificial object, a light sail created by an alien civilization. He argued the acceleration could be explained by sunlight pressure acting on a very thin, very light surface. The mainstream scientific community met this with massive skepticism. They scrambled to find natural explanations: hidden jets of hydrogen gas, exotic ices that sublimate without visible traces. But none of the explanations fit the data perfectly. Oumuamua was an anomaly, a ghost that appeared, baffled everyone, and disappeared back into the darkness, leaving us with more questions than answers. Now we have 3I Atlas. It's almost like Oumuamua's bigger, louder cousin. Where Oumuamua's push was invisible, Atlas's propulsion is on full display with its glowing sunward tail. Where Oumuamua's composition was a complete mystery, Atlas gives us a chemical signature so strange it might as well be alien. The parallel is undeniable. The statistical reality is staggering. Two such profound anomalies in just 8 years? These objects might be far more common in our galaxy than random chance would allow. Are these just two examples of a bizarre new class of natural object we never knew existed? Or are we seeing something else entirely? 3. Atlas isn't just a standalone mystery. It's a repeating pattern. It forces us to take the more out there idea ideas about Oumuamua seriously. The universe is showing us something that breaks our models, and it has done it twice. The strangest test of all is approaching fast. October 30th, 2025. 3. Atlas will pass closest to the Sun, and we won't be able to see it. This moment is called perihelion, the point where an object reaches minimum distance from the Sun and experiences maximum heat and radiation. For a comet, it's the ultimate stress test. Ice evaporates at peak rates, hidden volatile materials burst free. The object's true nature gets revealed under the most extreme conditions possible. But there's a catch, a massive one. As 3. Atlas makes this critical pass, it will be on the far side of the Sun from Earth's perspective. The comet will disappear behind the Sun's blinding glare in what's called a solar conjunction. For weeks, every telescope on Earth and in orbit will be effectively blind. The Sun's overwhelming brightness drowns out anything near it. No optical instruments, no radio telescopes, no way to watch what happens during the most important moment of this object's journey. This timing has astronomers simultaneously fascinated and frustrated, because perihelion isn't just when things get dramatic, it's when orbital mechanics become incredibly sensitive to change. At perihelion, an object has its highest kinetic energy, maximum velocity through the strongest part of the Sun's gravitational field. In this configuration, even a small change in speed or direction creates massive alterations to the future trajectory. Spacecraft engineers know this intimately. If you want to change course efficiently, to slow down and enter orbit, or boost toward a different destination, you perform what's called a perihelion burn. You fire your engines at closest approach, because that's when the same amount of thrust produces the biggest effect. If 3I Atlas wanted to alter its path, to break into a solar orbit instead of shooting back out into interstellar space, this is exactly when it would do it, and it would be completely hidden from observation. The uncomfortable coincidence hangs in the air. The most critical moment in this object's passage happens during the only time we can't watch. Is this timing cosmic bad luck, or suspiciously convenient? Scientists are preparing for what comes next. When 3I Atlas emerges from behind the Sun in November, they will measure its trajectory with extreme precision. Every observatory capable of tracking it will be coordinated. If its path has changed in ways that solar gravity and observed outgassing can't account for, the conversation changes dramatically. Any unexplained course alteration will be impossible to ignore. Let's talk honestly about what we're seeing. A comet with a tail pointing toward the Sun instead of away. A propulsion system producing thrust comparable to our ion engines. A chemical composition screaming foreign origin, with metals appearing in patterns we don't see locally. A trajectory aligned with our planets in ways that defy probability. And a perihelion passage happening precisely when we can't observe it. Each anomaly, taken alone, might have a natural explanation. Unusual outgassing, exotic ices from a different stellar environment, coincidental timing. But together, the stack of improbabilities becomes harder to dismiss with each new observation. The establishment insists we're missing something fundamental about how comets from other star systems behave. Perhaps the physics of objects born around different types of stars, in molecular clouds with radically different compositions, produces phenomena we've never encountered. # at meta, arf, pause, generated, decentralized. Our sample size of interstellar visitors is painfully small. 3 objects across human history. We're drawing conclusions from almost no data, but renegade voices, scientists willing to ask uncomfortable questions, are wondering if we're witnessing something that challenges our assumptions about what's possible. The perihelion pass will provide crucial answers. When 3I Atlas emerges from solar conjunction, measurements taken in those first days will tell us whether its trajectory has changed in unexplained ways. If it has, if the math doesn't add up with natural forces alone, the implications shift from curiosity to something far more profound. This isn't about jumping to conclusions. It's about following evidence wherever it leads, even when that path becomes uncomfortable. The universe is showing us something we don't understand, whether it's a natural phenomenon we've never seen before or something else entirely. It's expanding the boundaries of what we know is possible. In November, when Atlas re-emerges from behind the Sun, we'll finally know if this comet is just strange or the most important discovery in human history. Will its trajectory reveal natural forces we don't yet understand, or will it show signs of something engineered, something deliberate? The astronomical community is holding its breath. What do you think we're witnessing? A comet with physics we don't yet understand, or the first clear evidence of something beyond natural explanation? Drop your thoughts in the comments below. And if you want to stay updated on what happens when 3I Atlas re-emerges, when we finally get answers to the mystery that's kept astronomers awake at night, make sure you subscribe and hit that notification bell, because this story is far from over. Sometimes the universe doesn't give us answers, it gives us better questions. And right now, 3I Atlas is asking the biggest question question humanity has ever faced. We'll all find out together soon.